In consumer theory, we got used to interpreting the tangency between an indifference curve and a budget line as the optimal consumption bundle for the consumer. It therefore becomes tempting to interpret the tangency between an isoquant and an isocost as the profit-maximizing production plan for a producer. But it isn't that. This tangency between an isocost and an isoquant is simply the cost-minimizing input bundle for producing the output level that's represented by the isoquant. The profit-maximizing production plan certainly has to have this cost-minimizing feature, but it also has to have the feature that the output level itself is chosen so that the marginal revenue product of each of the inputs is equal to the input price. If we see an isoquant with a tangent isocost, we therefore cannot conclude that the production plan at the tangency is profit-maximizing. Along the ray from the origin on which this production plan lies, it may not be that the isoprofit is tangent to the production frontier, and the marginal revenue products are therefore equal to input prices. The production plan might be profit-maximizing, but it might not be. We'll explore this a bit here, and in the process we'll be able to conclude something about how input bundles change as input prices change. We'll start with one isoquant from a homothetic production technology, the isoquant that represents output level XA. For a given wage rate WA and rental rate RA, we get an isocost that's tangent at point A. In other words, the input bundle A is the input bundle that represents the least cost way of producing XA units of the output. Without saying more, we can't conclude that it's the profit-maximizing way of producing, because we don't know if XA is the right quantity to produce. In order to assume that, we have to further assume that the marginal revenue product of labor and capital is equal to the wage and the rental rate at the production plan A. Let's make that assumption, and so we're now assuming that the production plan A is in fact the profit-maximizing production plan given the wage WA, the rental rate RA, and some price PA. Since we've assumed that the production process is homothetic, the slopes of all isoquants along a ray from the origin will be the same. Therefore, if A is the cost-minimizing way of producing XA, then all cost-minimizing input bundles for all other levels of output must lie on the ray from the origin that passes through point A. In other words, as long as the wage and rental rate are WA and RA, there's a tangency between an isocost and an isoquant at every point on the ray from the origin that passes through point A. What's unique about point A is that at the current output price PA, the production plan A is the profit-maximizing production plan, which implies that if we looked at the slice of the production frontier that occurs along this ray from the origin, the isoprofit plane would be tangent at point A, and that in turn means that the marginal revenue products of the inputs are equal to the input prices. If the output price changes, we're going to move along this ray from the origin, because so long as the input prices don't change, this ray still represents the input bundles that are cost-minimizing ways of producing. If the output price increases, for instance, we will produce more, because the isoprofit plane will become shallower, and we will therefore move to a higher point on the slice of the production frontier along this ray. If the output price falls, we'll decrease our production but still stay on this ray, or if it falls sufficiently far, we might stop producing. Suppose now that the wage drops instead. There are two things that we know from our previous work. One is that a drop in the wage will cause a rightward shift in the marginal cost curve, and as a result a rightward shift in the firm's supply curve. So for any given level of price, the firm will produce more. Thus, the new profit-maximizing production plan must lie on a higher isoquant than it did before the wage dropped. Second, we know that a drop in the wage causes the isocost lines to become shallower, and thus the tangencies between isocosts and isoquants will fall on the shallower portions of the isoquants. In other words, the ray from the origin that represents cost-minimizing input bundles will now be shallower as a result of the drop in the wage. Putting these two insights together, we can conclude that the new profit-maximizing production plan must lie above the blue isoquant and below the initial ray from the origin, thus giving us the shaded area in the graph. An increase in the rental rate will also cause the isocosts to become shallower, and therefore implies that the new cost-minimizing ray from the origin will be shallower than the original ray. But an increase in the rental rate will cause the marginal cost curve to shift to the left, and therefore for any given price the firm will produce less. Thus output will fall below its original level. Putting these two insights together, we can conclude that an increase in the rental rate will cause the new profit-maximizing production plan to lie below the blue isoquant and below the original ray from the origin. This gives us the shaded area marked as an increase in the rental rate. An increase in the wage rate will also cause the marginal cost curve to shift to the left, which implies that at any given price the firm will produce less. Thus an increase in the wage causes output to fall. At the same time, an increase in the wage also causes isocosts to become steeper, implying that tangencies between isocosts and isoquants will occur on the steeper portions of the isoquants. This then implies that the new ray of cost-minimizing input bundles will be steeper than the original ray. We can therefore conclude that the new profit-maximizing production plan that results from an increase in the wage must lie below the original isoquant and above the original ray from the origin. A decrease in the rental rate causes a similar steepening of the isocost lines, and therefore a similar steepening of the ray on which all the cost-minimizing input bundles lie. At the same time, a drop in the rental rate reduces marginal costs and therefore causes a rightward shift in the firm's supply curve, which in turn implies that for any given output price the firm will increase its output. Thus, a drop in the rental rate will cause the new profit-maximizing production plan to lie above the original ray from the origin, as well as above the original isoquant. There are some interesting preliminary conclusions that we can see emerging from this graph, conclusions which will flush out more in the upcoming graphs. Consider, for instance, what happens when the wage decreases. A decrease in the wage will result in a new profit-maximizing production plan lying somewhere in the shaded blue region. All the production plans in that region contain more labor than LA. In other words, a drop in the wage will unambiguously cause us to hire more labor. But it's not clear whether it will cause us to hire more capital or less. There are production plans within that shaded blue area that contain more capital than KA, and there are production plans that contain less capital than KA. Therefore, we can't be sure without knowing something more about the production technology what the impact of a drop in the wage is on the amount of capital that we hire. You can find similar relationships in the other shaded areas.